Morning. Hello, everyone. My name is Sanjay Attar, and I am a Principal Solutions Architect with AWS, based out of New York. Within AWS, I work within our global accounts team, which covers some of our largest customers, Fortune 500 companies. Shortly later in this presentation, you'll be hearing from Zed Massoud, who is one of our customers, who's part of Lifion, which is part of ADP. The topic we have for today is Lifion's cloud transformation journey. Before we jump into Lifion's cloud transformation journey, I'd like to spend a few minutes with all of you to give you a brief overview of cloud transformation in general. And I'd also like to talk to you about what I've seen customers do in terms of some of the decisions they've taken and actions they've taken to be successful in their cloud transformation. Quick show of hands here. How many of you within your organization have a cloud-first approach organization-wide for any new development or deployment going into the cloud? Okay, so I'd say about 30 to 35% of you. Now, keep your hands up if these deployments that you have running in the cloud are cloud native. And let me define what cloud native means. So you have your architecture is completely microservices based. You're using containers, you're using blue-green deployments, you're using continuous deployment automation and DevOps. Okay, I'd say roughly about 10% of you had your hands up. So Capgemini did a study, and what they found is only 15% of organizations use a cloud native approach. And that number is expected to double to 30% by 2020. Now, when we look at cloud adoption today, it seems very ubiquitous. I remember, about 4 or 5 years ago, I would hear people talk about cloud being the new normal. Today, I think cloud is normal. But still, why do we have such a low percentage of cloud native, deployments running in AWS or in the cloud? So there's several challenges that organizations face and enterprises face when it comes to being able to run cloud native. And legacy infrastructure is definitely something most enterprises have, especially if you're a large organization that's been in business for a while. You're definitely going to have these legacy applications, these monoliths that companies don't want to invest in to make them cloud native. You heard in Andy's keynote yesterday. Legacy applications a lot of times have old guard technologies or old guard vendors that they deal with for their where they're running proprietary databases, and we do have several tools. So Werner this morning talked about the cloud native databases that we have and how you can use database migration service to really move off some of these proprietary databases. But it's really not the technology. I think we're all technologists here. We're smart people, and we figure things out. If there's a challenge, we figure out a solution for it, or if not, we figure out a workaround. And what even Forbes said is really the challenges is beyond technology, and it really goes into the people, the process, and the skills. So today, AWS has millions of customers, and what we've seen is certain patterns in how customers adopt the cloud and how they evolve and mature and reinvent themselves in the cloud. And we see customers go through 4 key stages as they go about this journey. So the first stage is the project stage. So this is typically, we saw this in early days, in the enterprise, where many enterprises were skeptical about cloud, and they thought, cloud is really something for, like the startups and maybe like the small shops, and, cloud is not really something that's enterprise ready. So the trend we started seeing was sometimes you had, maybe a business unit that would just go out there and pick a specific project or a specific workload and run it in the cloud. And sometimes without the knowledge of central IT, so that's your classic shadow IT. And the next stage we saw, companies move from that project stage where it no longer was a science project. Now, companies are moving into that foundational stage, and I'm speaking about enterprises. So enterprises wanted to really, they saw some success with some of these workloads running in the cloud, and they also wanted to kind of pull in some of these business units that may have gone rogue. So they really wanted to try to get ahead of that curve and get to that foundational stage where they wanted to build a hybrid cloud strategy. So in this foundational stage, you're talking about where you definitely need central IT. It's going to be hard to move into that hybrid cloud strategy without central IT, because you're looking at things like getting VPN set up, getting direct connect set up, building a landing zone. So this is the stage where central IT is building their hybrid strategy, where they're looking at maybe a cloud-first approach, where anything new, they don't put it in the data center and anything new goes in the cloud. Or maybe they're looking at using AWS as a target for all their disaster recovery applications. The next stage from there, where we saw companies evolve or move to, in this evolution, was the migration stage. So, at the foundation stage, you had some workloads running in the cloud. Enterprises, had, and they started realizing the benefits of, trading CapEx versus OpEx. They started seeing lower costs, the agility, and the elasticity that the cloud has to offer. And this is the point we started seeing enterprises, start to move significant workloads now. Now you're talking about mission-critical applications, SAP, some of the core business systems started moving into the cloud. The last stage, and this is like the nirvana stage where everybody wants to get to, is where you're fully optimized, you're completely cloud native, as we talked about, where everything is automated, you're leveraging DevOps, and everybody's in a happy place. This is where everybody wants to be at, but it does take, it does have some challenges that we looked at earlier, and this is a stage where companies really want to see how they can really get the full benefit of the cloud platform. Because at this point, yes, AWS does have a very vast set of services. It's not just a set of building blocks, but it's getting the benefit of the entire platform, and where you can really be optimized to harness the full benefits that the AWS cloud has to offer. So let's take a look at what are some of these ingredients. So in seeing all these customers go through their journey, there's 5 key ingredients that I see customers execute when it comes to having a successful cloud transformation. So the first one is executive sponsorship. I know before AWS, I was an enterprise architect, working for a large professional services organization, and I was working on a cloud strategy. I did get executive, a sponsorship to back me up on the cloud transformation that I was working on, but I really didn't take it up to the senior most levels, and I got to a point where the project just fell apart. So this is where I see, even some customers stumble with this, where really when it comes to executive sponsorship, you really want to go at the highest levels. So we're talking about CIOs, CISOs, CTOs. So you really want to get to the highest level of executive sponsorship, because this would help you avoid any potential roadblocks, because you're talking about a cloud transformation program. So you really want to define the program, you want to have milestones, you want to have dates, you want to have tasks, you want to have like project managers assigned, you want to have resources assigned who are actually going to be assigned to this program, so you can execute this strategy. The next thing is DevOps. I think through the course of this week, you've probably heard of DevOps 100 times. So DevOps basically is more than the tools. I mean, it's definitely about the tools and technology, but it's a lot more about the culture. So this is what makes that executive sponsorship, we talked about earlier, important, because you're talking about a cultural change within the organization. And usually cultural change is always defined, from the top down. So, basically DevOps, is a combination of cultural philosophies, practices, and tools that basically increases an organization's ability to deliver applications at a very high velocity. And since it requires cultural change, there's teams that need new roles and new responsibilities in this new way of doing business, or new way of delivering applications. So these teams need to have their roles and responsibilities clearly defined. There needs to be trust between teams. So the entire process works like a well-oiled machine. Experiment. Now, I know this is something which scares a lot of CISOs and executives. The whole idea of being able to experiment. Many times, especially CISOs are concerned about security and the sanity of the environment, when there's experiments going on. And this goes back to that culture where I've seen organizations that build that culture of innovation, really get good at really get good at being able to transform their cloud program. So normally, failure is perceived in a very bad way in the enterprise. So it's really changing that culture where it's okay to fail. And it's okay to fail fast as long as you can get back up on your feet and try a different way of doing things. And that's basically what's going to help you drive innovation. And in terms of organizationally, many enterprises that have been in business for many, many years are actually afraid that you may have a couple of college kids who just came out of college, start off in a garage, they get some services from AWS, and they could potentially put long-standing enterprises out of business. So what I see some customers do is rather than being disrupted by these college kids, they set up their own internal disruption business units within the organization. And you'll actually hear from Lifion, which I think is an extremely smart thing that ADP has done, is creating something like a Lifion, which is that internal disruptor. Training and enablement. So, through this week, we've heard the several dozens of announcements, through the week, through the keynotes and through some of the breakouts. So, one thing with the cloud is that the pace is extremely, it's extremely fast-paced. And, really staying up to date with the skills is going to be critical for enterprises that are looking to really transform themselves in the cloud. So, by the fact that you're here is excellent. You're all getting educated, you're learning. So, you want to have, a mix of, either conferences, formal training, informal training, and this would really help, accelerate that cloud adoption. And the other challenge I see with customers is they want to jump on the cloud bandwagon, but a lot of times their people are not having the right skills, and they have the same mindset in the way how they design and architect and build on-premise systems. They bring that into the cloud, and that really is not efficient. And I've seen instances with customers where their costs sometimes are going up because they're really not trained to take advantage of all the tools that the cloud has to offer, where they can really keep their costs low and be in that cloud-native environment where things elastically grow and shrink, and you can use things like serverless Aurora, Lambda, Dynamo to really reduce your costs and take advantage of the broader platform. So IDC has actually published some research in terms of some stats, as you can see on the slide. They've seen 80% organizations that have their people trained and enabled and empowered see 80% faster adoption to cloud. Close to 3 times a jump start in the innovation, and over 4 times, being able to overcome any sort of operational and performance concerns. Okay, and the last thing I wanted to touch on, and not the least, is the Cloud Center of Excellence. I cannot stress on this, more. I mean, the Cloud Center of Excellence is really going to be your engine that drives that cloud transformation process. So really, the Cloud Center of Excellence is going to be your cross-functional team, made up of people, representing different business units within your organization. And in enterprises, there's a tendency to be very siloed. And what I see with the larger enterprises is that duplication of efforts. I see different silos of teams trying to solve the same problem, and they're kind of banging their heads against the wall. And having this Cloud Center of Excellence would really help create standard processes, across the organization, standard patterns that can be reused, and you'd be able to eliminate all this duplication efforts, and you'd be able to have the right guardrails for teams to be able to innovate, to be fast, and to be secure at the same time, using DevOps and DevSecOps. With that, I'd actually like to hand it off to Zed Massoud. So Zed actually is the lead principal architect at Lifion, and he actually works with 200 plus engineers within the Lifion organization. And he's been the central and key for spearheading the cloud transformation efforts at Lifion. So I'd like to invite Zed, who's going to talk to you about how Lifion has transformed their cloud journey.
Thanks, Sanjay. Hey guys, so I'm Zed Massoud. I work with Lifion. So what I'm going to do is take the next 20 to 30 minutes or so and tell you guys a bit more about our journey. And I'm going to start with a little bit of an overview of our business, what we do, and then spend a bit of time talking about the journey that we've taken on in the last 2 or 3 years or so. This is a 300-level session, so towards the end of it, we are going to do a bit of a deep dive into some of the managed services we've adopted, including Kinesis, DynamoDB, Aurora, and ElastiCache. And we're going to be talking a bit about our learnings on that, and we're going to leave a few minutes at the end for questions. So a lot of people, know us as a payroll company, and that's true. Payroll is absolutely a large part of our business. We pay about 1 in 6 people in the United States, but ADP is a lot more than that. Over the last several years, we've been transitioning from a services company more and more towards a technology company, and human capital management is a big part of our business. We're about 58,000 people around the world, so it's a large, complex enterprise. And many of our products span the full human capital management, or HCM, space. So HCM includes a wide variety of products, including things like managing time, performance management, integrating with things like benefits and payroll integrations, how we manage people data and organizational structures, how we do things like approval flows, compliance efforts, and various different integrations with customer systems as well. But one of the things we've done is really invested heavily in next-gen programs, and Lifion is one of ADP's next-gen programs. It's really helping us to lay a solid foundation for our future. We're competing in an increasingly competitive market with startups and others that are playing a big role in this space. What we've really done is helped infuse a broader organizational disruption. We're doing things like cloud-native architectures, improved user experiences, and it's really a big part of our strategy is investing in these next-gen programs. So I'm going to take us through some more details into what we've done at Lifion. So just to give you guys a bit of background about what is our Lifion's business, what we do, the platform we're building, it's really a low-code human capital management app development platform, right? So human capital management apps have a lot of customization needs. They're quite complex compared to a lot of other apps in the industry. There's compliance needs in different regions. There's areas where we need to customize aspects of the functionality for certain clients. So really what we're doing is building something that lets you build human capital management apps with a low-code approach. So this gives us high velocity, and it helps us customize our apps for individual cases without managing very complex code behind it. Some of our key business differentiators: we're truly global from the ground up. These are things that are differentiating for us. It's a rapid product development approach, so meaning that you can build out complex business logic and workflows using a low-code development approach. And really an app ecosystem something we call HR your way. So what we're seeing with one of the trends we're seeing with our customers is that there's a lot of demand for having HR done in exactly the way you do business. And this is really one of the things that our platform enables is a app ecosystem where you can use specific apps that work for you. Dynamic teams, different from more traditional organizational hierarchies. Customers using things like agile teams or things like matrix organizational structures, and that's something else that we're building into this platform. More and more trends towards gig economy, different types of worker preferences, more sort of temporary worker preferences, and that's something that we have as one of our product differentiators as well. But the biggest one, I think, for us for this session is really the cloud-native HCM. And this is something we're actually seeing resonate within our market. From a marketing effort, we're actually saying that we're a cloud-native HCM today, and we're finding that it's resonating with our customers, both from an interest perspective in terms of what it means to be cloud-native, but also as a customer, you might wonder, well, how does it actually benefit me? And we are finding that customers are feeling that because of the cloud native nature of our underlying technology, that there will be a translation to them in terms of what it means for reliability, uptime, and the way we do deployments, and the way we push out application updates. So this is something we're going to continue to see more and more from a marketing perspective as a cloud native HCM. We've added we've more than doubled in size in the last 2 years, so we're 461 people around the world today. We've got 5 pilot customers, and we're looking to increase that quite aggressively within the next couple of years. We've got a microservices-based ecosystem. We are 160-odd microservices, and I'm going to get a bit more into detail about the architecture behind that. We're using 7 public cloud services today with AWS, and we've got a rich ecosystem of human capital management apps. Some of the advantages we've seen with microservices include teams having full control over their services from start to bottom. You build it, you ship it. Yeah, you build it, you ship it. Yeah, and these teams take full ownership from the UI level to the database level to the application level, and they're very, very well aware of how their infrastructure looks. So Lifion itself was born in the cloud. This is what our architecture looked like about 2 to 3 years ago. The first thing we did, our first version of Lifion, everything was on EC2. So looking at things like our container orchestration and scheduling framework, back in 2015, we were running Docker Swarm. Microservices, 160-odd microservices with a variety of runtimes. Primarily Node.js is more than 90% of our services. UI with React, a bit of usage of Python, Scala, and Go as well. And this was a Docker Swarm cluster running on EC2. And then we have our service discovery mechanisms, and then a bunch of different databases. So using a sort of a polyglot persistence approach with the right database for the job. We had a multi-master MySQL solution running on EC2. We had a distributed document database also running on EC2, graph database, search database, as well as data streaming brokers, all running on EC2. And this meant that our teams took on a large span of control, from OS level concerns, things like AMIs, to patching, to upgrades, how we provision our clusters, how we manage our infrastructure as code, how we do failovers, how we look at high availability. What does it mean for one of our nodes in all of our distributed databases? What does it mean for them to fail? How long does it take for it to come back up? Backup approaches. And this is the span of the things that we were looking at. And in some respects, you might think that this sort of looks like something that you might have taken from a data center and put it into the cloud. So our key operational goals that we sat down, we defined, we wanted highly available, scalable, maintainable infrastructure. Our infrastructure as code strategy, we wanted it to be highly repeatable so that we could provision new environments quickly. We wanted to minimize our operational complexity. So all the things our teams were doing with some of the aspects I'd mentioned before were things that we found were taking quite a lot of time. And in a microservices architecture, workload isolation is very critical, and we found that over the last several years. So when we have service teams that are using all of our various databases, what does it mean for one of those services to be putting a high workload, and how that affects other workloads? And with our database clusters, that was something that we found we really wanted to help improve. So to tell you more about our the drivers behind our adoption of managed services, we've got Lohit Sarma. He's our VP of Product Development, and he leads our Lifion Developer Platform organization, and it's a very short message from him.
Lifion is ADP's next generation HCM platform. We're fully owned by ADP, but we function as a startup inside ADP. The main goal of Lifion is to help accelerate ADP's digital transformation. So why do we choose to go with managed services? Like most modern applications, Lifion was born in the cloud. We're powered by microservices. And with every microservice application, each engineering team owns the services and its data store. But what we noticed is as we began to scale, the operational complexity of managing these stores started to increase. We started noticing the engineering teams are spending a lot of time on just maintaining the tech stack as opposed to concentrating on the core product differentiators. So around last December, we sat down and asked ourselves, why are we spending so much time on just maintaining the stores as opposed to building out the product? That's when we decided to make the bet on managed services. Over the past 10 months, as we began to adopt the managed services, there have been a few learnings. And as we begin to scale out our applications, we want to start releasing these learnings out to the community. Over the next 2 months, we will be incorporating this into a few open source releases, which we hope the community can adopt and it can be beneficial for the community. If someone were to ask me what the biggest wins were over the past year, I'd say moving across to managed services was one of them.
So what we started seeing when we analyzed all these managed services, really the operational burden was a big factor that we considered. Workload isolation within a microservices framework is something I mentioned earlier, but how do we use the easier ability to provision services, and how can we use that effectively to isolate workloads within our services ecosystem? So each service can have its own, whether it's like a Aurora cluster or an SQS queue or a Kinesis stream or a DynamoDB table. That's something that's actually isolated to that service versus having a shared multi-master MySQL database or other document database that different service teams are connecting and trying to figure out what is the right partitioning approach. How do we segment that data between different service teams? And that's something that we found was a big factor here. Reliability is extremely important. So each of the services that we looked at, we looked at what are the multi-AZ capabilities of these services, what happens in case of an AZ failure, how does our application respond to an availability zone failure, have we made sure all of our drivers and all of our connectivity from the application level to these various services responds effectively. And then the sort of the fixed cost versus the pay-per-use billing model. So, are we provisioning all these EC2 instances for our peak capacity for the next 8 to 12 months? Or are we able to use more of an on-demand approach where we can pay for what we use with services like Kinesis or Dynamo, or more of a capacity-based billing model? These are the databases we use today. For relational database, we use Aurora. Dynamo primarily for key value storage. There's some document database storage there as well. ElastiCache for scalable in-memory caching needs, and AWS Elasticsearch service as well for our search capabilities. And I'm going to dig a little bit deeper into some of these shortly. Kinesis we're using for two different key use cases. One is really for data replication between different stores. So data coming in from a relational database, how that then replicates to other data stores. We're going to talk about a couple of examples of that. For cases where we have a single consumer, where it's much more contained, we're using SQS, and we found that to be quite a simple service to adopt as well. S3 and CloudFront for content storage and CDN purposes. So edge-to-edge cache locations with CDN, so our customers are downloading static assets closest to their edge location. We're evaluating EKS and NEPTUNE today. So we are migrating to Kubernetes. That's something that's in the works. And EKS is something that we're evaluating for future adoption. And NEPTUNE for graph database storage. So a big part of the data we have, there's organizational structures and hierarchies, and how do we traverse those structures? How do we find somebody up the organizational hierarchy who's not on vacation who can approve a certain request, as an example? So we are using graph databases for that. NEPTUNE is something that we've been following closely. We've been in touch with that team, and we're considering adopting it shortly. So like I said, so this is a 300 level session. So we are going to go a little bit deeper into some of our key services that we use and talk more about how we use them and what have been some of our learnings in using these services. Kinesis today we're using for 3 key use cases. So change data capture. So when we have system of record data that changes, how do we then stream that onto a stream so that consumers can react to that and capture those changes? So the graph database example I mentioned earlier, when we have a change in a system of record data, that then gets propagated to a Kinesis stream, which will then be consumed by a reactor that writes it to our graph database. So that's how we keep that consistent. And then event-driven flows. So for example, there's events happening in the system. A new user is created, a new employee is created for a customer. That is an event that then there's downstream consumers responding to that and doing what they need to do in order to make sure that they're ready for that event to occur. One of the things we saw in our Kinesis client library deployment consideration. So Kinesis was, from a serverless model, like streams are very easy to create. But one of the things, the client library itself is a JVM process, and that runs. So you need to actually run that over alongside your other services and have that communicate with your services using standard out. So this might work in some scenarios if you've got a lot of JVM services, but in our case, like we have NodeJS services, so there was a lot to consider around how you deploy that, right? Our logging framework used standard out, so that in itself was something that we'd found would conflict with Kinesis. And outside the JVM space, there's sort of this multi-lang daemon, which is a JVM process that's deployed alongside your other services that communicates over standard out. So what we started to do is really look at what are the options here. And one of the things that we made a decision on earlier this year when we started adopting this is to develop a native Node.js Kinesis library. And we're actually happy to announce we've been using this in production since the beginning of the year, so it's got more than 6 months of production use. We've recently taken that and created an open source version of it, and that's actually available now. So the Lifion Kinesis Client it's a native Node.js consumer and producer library. We're actively maintaining it. There's a fair amount of development happening as we speak. But it already includes enhanced fan-out support. So enhanced fan-out support is a feature that the Kinesis team launched in August this year. And we've got a native Node.js client with enhanced fan-out support. We're also going to be adding the classic APIs to use with this, and that'll be coming shortly. So the other service we spent a fair amount of time looking at was DynamoDB. And we liked the sort of serverless nature of DynamoDB, no nodes to manage, no nodes to create. The capacity model being very fluid, your ability to just provision capacity as you need it. We found it worked well for our key value use cases, but really need to validate your document storage use cases. If you're used to databases with nested array querying or sub-object querying, then that's really something you want to take a look at very carefully. It worked really well for us for smaller item sizes. Things that are single-digit kilobytes work quite well. As item size increases, the billing unit with Dynamo is based on the item size. So for each kilobyte or so, you're basically doubling your capacity unit. So it works really, really nicely for small item sizes. We did end up enabling a feature in our library where we split up larger documents and put part of them onto S3, kept the smaller amount of the document that was just needed for querying in the DynamoDB item. Autoscaling can be nice if you have sustained periods of load increases. If you have very spiky loads, so if you've got a sudden increase that just decreases quickly after that, autoscaling does take time to take effect. But burst capacity is something that can help there because you basically get a credit of the last 5 minutes to use in the next 5 minutes if you haven't used that capacity in the last 5 minutes. So if you've got low usage, you can go maybe 50 to 100% of your provision capacity on burst capacity. If you saw the keynote yesterday, there's an announcement on this with on-demand capacity, and that's something that can help with some of these use cases. So that's something that we're evaluating as well. So previous to Aurora, like I mentioned, we were using a multi-master MySQL database, and we really started looking at what's it going to mean for us to have a highly available, reliable Aurora clusters, and what does it mean from performance point of view, and a couple of other learnings on that as well. So one of the key things, just from an availability perspective, we realized is that the storage layer, as a shared storage layer, is already highly available. And therefore, the compute instances you're deploying with Aurora in themselves are only providing high availability for the compute level, not for the storage level. So just from a high availability perspective, you only really need a single read replica. Whereas in other systems, you might need to look at quorum. You need to make sure that the majority of your nodes are available at the compute level. In kind of multi-master approaches, you need to make sure that you have at least 3 nodes deployed. But with Aurora, because the storage level itself is shared by all compute nodes and it's highly available in itself, we actually only need 2 Aurora instances for high availability. And that helped from a cost analysis perspective. EC2, comparing the price of an EC2 instance versus the price of an Aurora instance, Aurora will be higher, but in our case, we needed less nodes than we needed on EC2. There's a lot of kind of documented performance improvements with Aurora. You'll hear 5 times performance improvements. Those work really well with concurrent querying patterns. So, if you've got a lot of concurrent querying, we saw performance improvements. Long-running queries are a different profile. So if you're comparing long-running queries on Aurora versus a vanilla MySQL or Postgres or something written on on EC2, you're going to find some variations there. Point-in-time recovery, really important feature. Really helped us sort of simplify our backup processes. Binary logs is something we need for change data capture, so we have binary logging enabled today. but enabling binary logging does add time to failover. So that's something there are improvements in progress on that already, and I think the team's well aware of, the Aurora team is well aware of that. So we also use ElastiCache. ElastiCache has both a memcached and Redis engine. And there's various different comparisons you can do between these two engines. And one of the big drivers for us was availability. So really the biggest thing, the fact that the Redis engine does offer high availability and is multi-AZ, whereas memcached is a single instance. That's what tipped the balance in favor of Redis, because we want to have read replicas, we want to be multi-AZ, and we want to be resilient to availability zone failures. And that was why we used Redis, in addition to the kind of the broad support within the ecosystem of things like client drivers and others as well. ElastiCache, I would say, has probably been one of our smoothest adoptions out of the ones that we've discussed here. I think we found the driver ecosystem to be quite resilient, and we've also seen that the maturity of the product. There's been quite a few iterations. We're on a 4x version of ElastiCache, so we did not see any real issues from an adoption perspective. We had our teams just really using Node Redis drivers, pushing it out, and we were in production in some cases in a period of about 2 months with ElastiCache. With the Redis engine, you also get two options. You get cluster mode and non-cluster mode. Non-cluster mode is the easiest to implement and deploy, but it limits horizontal scaling. So there is a little bit more complexity on the read side, but in terms of scaling operations, you can vertical scale, but if you do vertical scaling, there will be a period of blocked reads and writes in vertical scaling. And what you can work around that. You can have retries in your application logic, and that can help. But the alternative is to go with cluster mode, but start with a single shard. So, meaning that when we first went out to production with ElastiCache, we were in cluster mode. We had a single shard. So what this does is it enables us to grow horizontally and add additional shards in the future. And we've included we've made sure that the application is ready to add additional shards in the future. And that's entirely an online operation with cluster mode. So as long as your Redis driver is cluster mode aware, it'll be able to pick up any changes that happen in the cluster configuration and respond to that entirely online. We had to take a close look at sizing. So since everything is in memory, we want to project out exactly how much memory we might be using over the next 12 to 18 months and provision our clusters accordingly. And then what is the eviction policy? What happens when you do run out of memory? What is it that's getting evicted first? Is it the least recently used? Is it is it based on a TTL that you've set? So that was something that we had to take quite a bit of time to invest up front and make sure that those decisions are made well. What we've seen with Redis is the retrieval times have been extremely fast, sub-millisecond in most cases. And it's been really helpful for use cases where there's really low latency operations required throughout our ecosystem. One of the issues that you come up with when adopting an in-memory cache is what's the failure strategy. So what happens if there's a node failure? What happens if you could lose all your data? It's something you have to plan around. So the ElastiCache does offer daily backups to S3. So that's something we've enabled. So daily there's a snapshot taken of your ElastiCache data and written to S3, and that can be restored if required. So injecting new ideas and fresh talent is something that can really help turbocharge a cloud-native transformation. One of the things we've done is, like I mentioned, the growth over the last 2 years, about more than twice the amount of growth. Most of the people at Lifion are new hires from various parts of the industry, so folks that have worked in different kind of entrepreneurial backgrounds and setups, as well as different areas of the industry. So we've really injected a lot of fresh talent and ideas into the organization. And if you are thinking of a cloud transformation, the one thing I'd say to take away from this is to really spend some time up front investing in more of a cloud-native architecture, looking at managed services, looking at the fit for what those services could have for your application, rather than saying we've got this application running on a data center, let's pick it up and put it into EC2. But really, from our journey, from our experience, we started there, we transformed afterwards, and so if you're taking that time up front to really do that analysis, whichever direction you decide to go, you'll know what the reasons for that are, and you'll have a plan for the future in terms of what your strategy is. So I'm going to turn it over to Sanjay to wrap up, and then we're going to have a Q&A.
Great. Thank you, Zed. That was actually a great story, with Lifion, transforming themselves. Being a born in the cloud startup, they really put these 5 ingredients together. You see at the bottom of the slide, where they had the sponsorship, they have that culture of innovation, and they infused their teams with DevOps. They got educated, they built that CCOE. So very, exciting to see them, transform, and be part of their journey. So that wraps up, this session. I know we're standing between you and lunch, so please do take a couple of minutes to fill out the survey because we'd love to hear your feedback so we can make these sessions better. And we'll be available if anyone has questions. We do have stand-up mics in the aisle, so if you have any questions, if you're bold enough to come up there, you can ask your question, or we'll be available down here if you have any questions and if you need to talk to us. Thank you, everyone. Thanks for coming.